The aim of this tutorial is interfacing ADC and DAC with 8085. We are using ADC 0800. It is a 8-bit ADC. There are different pins in it which are used by only interfacing devices to control and take data from it. Analog input pin, SOC pin, EOC pin and OE pin, which stands for start of conversion, end of conversion and output enable. Due different pins in ADC 0800, we need an extra peripheral device for its interfacing, which is 8155. It's a programmable peripheral interface compatible with 8085. 8085 sends data to 8155 using a data bus which can be given to I/O devices. 8155 has 3 ports: port A, port B, port C. These pins are interfaced with 8085. VCC supplies the supply voltage to the 8155. VSS provides the ground to 8155. Reset resets the 8155 to the previous stage. AD0 to 7 provides the address and data bus to 8155. IO M bar provides the input, output and memory signals to 8155. RD bar, WR bar provides read and write signals. ALE, address latch enable, helps in demultiplexing the address bus. Chip enable enables a chip at its time of functioning. This block diagram shows the various connections of different devices. This decoding logic is for selecting the 8155 chip. ADC is giving digital output to port A and port C is connected in handshaking mode. This figure is showing the assigned port for chip selection and various port addresses of 815. A7, A6, A5, A4, A3 are for enabling the chips and A2, A1, A0 are being used for addressing the various ports of 8155. These tables show the required configuration of control register to be sent to 8155. Port A is taking input from digital output of ADC. Port C is configured to be in all 3 mode. In this mode, PC5, PC4, PC3 act as output pins. PC2 is strobe, PC1 is BF signal and PC0 is for INTR. End of conversion is connected to PC2 and buffer full is connected to output enable. In this program, firstly we have to configure 8155 to use its various ports. Then SOC signal is sent through port C. Port C is configured in handshaking mode with ADC. 8085 reads 8-bit digital value from port A. 8085 stores the value at given address. The first 2 lines are used for configuring 8155 in the required mode. A small duration pulse on SOC input of ADC will start conversion process. SOC input of ADC is connected to port pin PC5 of port C. So value 20H followed by 00H starts the conversion. Now ADC resets EOC to low at end of conversion. 8155 sets BF to 1 to enable ADC output latch. 8085 is waiting for BF to be set to 1 and reads port A and resets BF signal to 0. Signal 1 is at BF will make value of status register 02H. So when we do its AND with 02H, result is non-zero. And 8085 reads the value from port A of 8155 by command in 11H. STA FC00H stores the value. Digital to analog converter B1 to B8 pins are used for input of digital data. I out gives the equivalent current. Reset. Rest of the pins R for voltage. As DAC does not require any control signal, so it could be directly interfaced with 8085 through a latch. Here port 01 along with IO and write signal is used to enable latch, and data lines are connected to the input of latch and output of latch to the digital input of DAC. Since output is current, so a I to V converter is used to get output. This program is used for interfacing 8085 with DAC. 89H is the required digital data to be converted into voltage, which is sent to the required port 01H to out command.